Compound interest refers to the interest calculated on the initial principal, as well as on the accumulated interest from previous periods. This principle allows investments to grow exponentially over time as earnings become part of the principal. Compound interest is crucial as it maximizes the return on investment by earning interest on interest. Over time, even small initial investments can lead to substantial financial growth due to its compounding effect. The principal is the original sum of money invested or loaned before interest. It is the foundation upon which compound interest is calculated and significantly impacts overall returns. The rate is the percentage at which interest accumulates on the principal over a certain period. It directly influences how quickly the investment grows, underscoring the importance of selecting optimal rates. Time is a critical component in compound interest calculations as the duration of the investment influences the total amount earned. The longer the investment period, the greater the returns due to compounding. Compounding frequency refers to how often interest is calculated and added to the principal. More frequent compounding periods can lead to higher total returns, emphasizing the need to understand these options. Montoya invests $50,000 at a 3% interest rate, compounded semi-annually. Total amount received in maturity is calculated by the formula A equals P times bracket 1 plus R slash N bracket to the exponent bracket N times T bracket. So that would be equal to the $50,000 times bracket 1 plus bracket 0.03 divided by the 2, which is semi-annually, bracket to the exponent of bracket 2 times 5 bracket, which results in approximately $58,027.04 after 5 years. Investing $100,000 at a 2% interest rate annually, compounded quarterly over 4 quarters, results in a total amount of approximately $102,015.05. And you do this by doing the $100,000 times bracket 1 plus bracket 0.02 divided by 4 quarters, bracket to the exponent of 4 quarters. This demonstrates how regular compounding increases the final amount significantly. To determine the initial capital that will grow to $17,715.61 in 6 years, a compounded annual rate of 10%, formula can be rearranged to solve for P. This results in a required initial investment of $10,000 equals to $17,715.61 divided by bracket 1.10 to the exponent 6. Frequencies is crucial in investment calculations. For example, capital growing at 8% compounded quarterly requires specific formulas that ensure accurate results as opposed to annually and monthly compounding, impacting total returns dramatically. 8% is divided by 1 for annually, 8% is divided by 12 for monthly, and 8% is divided by 4 for quarterly. Calculating future value shows how compound interest affects future value calculations and can guide investors making informed decisions about their capital deployment. Strategies to maximize returns include understanding compounding frequency, selecting higher interest rates, and investing for longer periods. The earlier one starts investing, the greater the potential for wealth accumulation to the power of compounding interest. Compound interest is a powerful tool for wealth building, enabling investments to grow exponentially over time. Understanding its mechanics and employing effective strategies can significantly enhance investment outcomes, as demonstrated in previous examples.